Hey, hello. Yeah, sorry for that.
That's okay.
Yeah, what was going on? What was the question?
Oh, we're just chatting.
Okay. Okay, so I can start anytime from now.
Awesome. Yeah, I think just before we dive into the actual walkthrough itself, I think it'd be great to give a little overview of what you guys do, what the kind of vision for the Fluid DEX is, and then maybe like a little intro about both of your roles on the team.
Yeah. Do you want to go or should I?
Yeah. So let me introduce you to Fluid. So Fluid, we call it a liquidity layer. On top of liquidity layer, we build different protocols. One of them is lending and borrowing market. The next one is coming DEX protocol. Everything is built on top of the same liquidity, which allows us to avoid liquidity fragmentation and also allows us to introduce novel concepts, especially with the Fluid DEX. So just a few words about Fluid Lending Protocol, that we allow the highest liquidation thresholds and lowest liquidation penalties in the industry. We have up to 97% LTs and as low as 0.1% liquidation penalties, which is not achievable by any other lending market in the space. And as I told you, the next big protocol we're launching is Fluid DEX, which Cantina auditors will be reviewing now. With the Fluid DEX, we introduced several novel concepts. And the most important one, I would say, in my opinion, is the introduction of what we call smart debt, which allows to utilize debt as a trading liquidity. This never happened in TradFi, DeFi, or CeFi. Users will turn their debt into a productive asset. How we achieve that? So let's imagine you have ETH collateral and USDC smart debt. So as a borrower, you accept that your debt can be in one or another token, that your debt can be in USDT or USDC. So basically, you have like a DEX LP risks. Yeah, when you provide DEX liquidity, you also have a risk that your LP can be in one or another token. So when a trade is happening, when a trade is routed through a smart debt, you can imagine that the trader is repaying one part of the debt and borrowing another part of the debt on behalf of the borrower. So instead of normal, let's say, swap function, you have this repay and borrow function. And yeah, this allows to change DEX landscape quite a lot because, for example, stablecoin providers, yeah, normally they incentivize this idle DEX liquidity on different AMMs, so people can swap in and out if required. With Fluid, they just need to have borrowing they want for their stablecoin. When users are borrowing the smart debt with, when users are borrowing smart debt, they're providing liquidity for the stablecoins. But the thing is that debt doesn't have tokens, debt doesn't have TVL. So users do not need to lock their TVL. They do not need to lock their liquidity. Just the debt is being utilized as liquidity. With smart collateral, it's basically a Fluid DEX LP, which can be used as a collateral on Fluid lending. So you earn both lending fees and trading KPR on top of your collateral, which makes the cost of your borrowing is less, and the cost of your the trading fees, the fees you're getting on your collateral are higher. And since this is a lending and borrowing market, you can leverage your collateral and your debt. So same you can do with smart collateral and smart debt. And if we're talking about pairs, like for example, stake ETH, users can leverage it up to 95% LTV, which equals to 20x leverage. And in the end, you will end up with a 20x collateral and 19x debt. But this is combined 39x of liquidity because both smart collateral and smart debt are used as trading liquidity. So a protocol which deposits only, let's say, 3 million TVL and leverages it, it can achieve more than 115 million in DEX LP. So it's there is no other DEX in existence that generates more than $1 in trading liquidity per $1 in DEX TVL. We have 39 times better efficiency, and yeah, so that's the most, let's say, high level overview. But there are more things to tell you about. For example, we can have just a DEX LP, which is not used as a smart collateral or smart debt. We call it, let's say, smart lending. And this DEX LP, it also earns both trading APR and lending APR. So the difference is the difference from smart collateral, that this smart lending cannot be used as a collateral on the lending market. But for DEX liquidity providers, it's still a better place to provide your liquidity on Fluid DEX because you have two sources of yield. Yeah, so this is the main features of the DEX, and we're very excited to launch it. I don't know if Samik has something to add about it, or if anyone from the audience have questions.
Yeah, I mean, I'll sort of also summarize everything in like one pointer, or like what you've described. So our fluid DEX is basically it's not a normal DEX. It allows smart collateral, smart debt. So basically, user can use their LP position as collateral while still earning lending APR and trading APR on top of it. Now, this collateral can be, if user wants to be ETH based, then they can have a ETH wrap stake it, let's say smart collateral. They're earning trading fees, they're earning lending APR, and they're using it as a collateral all together while borrowing anything. They can also borrow something like smart debt. Let's say if they want to borrow stable USDC debt, so it's stable USD debt, then they can borrow USDC and USDT as smart debt. So their debt is in stables, which is USDC, USDT, but traders can trade on top of this debt, earning them trading APR. So let's say if their borrow APR is 6%, trading APR is 3%, then their net borrow APR is basically 3% because they're earning trading APR on top of their debt. So this is the first thing in the financial world where you can where your debt is liquidity. So rather than being just a liability, you can use it as liquidity and earn on it. So that's I would say a big innovation here. And yeah, as DMH mentioned everything in pretty detailed. Aside from that, on the technical side, our DEX it follows the same XY equals to K Uniswap formula. Rather than having a lot of flexibility, it allows only one single range auto rebalancing range order. So user can deposit their tokens and forget about rebalancing. So it provides experience like Uniswap V2 where you just deposit your token and then you don't have to do anything. But the range can be set by the governance. So we can have a very tight range for stable pairs, a wide range for non-stable pairs, but overall allow users to get better capital efficiency with just single range order and experience like Uniswap V2. So they just deposited the liquidity and they don't have to rebalance or do anything because the DEX will auto rebalance itself. So yeah, I mean that's more or less the idea. Yeah. So how should I just directly dive into the code base or like is there something else? Okay, I hope everyone can see it. All right, so this is the scope of the overall code base. So Fluid code base is overall pretty large. In the scope, it's probably around 2,700, 800 lines of code base. But in reality, the entire Fluid protocol has probably around 6,000, 7,000 lines of code. But that's already live in production for like 5 months now, and is already handling about 400 million in TVL. So yeah, so basically, yeah.
Jump in. I think we might be looking at the screen.
You are not able to see my screen?
I can see
We-
your Discord screen, but I wasn't sure if you.
Oh, okay. Okay. I'll see. What's? Let me try again. Yeah. I think now you should be able to see entire screen once it goes live. Okay. I hope now it's visible. Yeah. Yeah, so on the audit scope, it's to around the all these files which are included in the folder contracts, protocol, DEX, pool T1. So inside of this is the entire pool code base, which has all the logics, algorithm, and everything. But as I said, the overall Fluid code base is pretty vast, and these things are already live. The landing protocol, just to show things on the screen as well, might be good. So, okay, maybe I'll just skip it. So yeah, so this is the landing protocol, which is already live. This is Vault protocol, which allows users to borrow. These are all already live on the production. And then there is ST protocol, which is also live, but there is no particular UI for it. So the new protocol that we are launching is DEX. How Fluid works is there is a base liquidity layer where entire liquidity stays of all the protocols. And on top of this liquidity layer, you can build infinite amount of protocols, and each protocol can serve different purpose. So, for example, we have landing protocol, which allows users to lend. We have vault protocol, which allows users to borrow while still earning lending APR. And we're launching DEX soon, but there can be many other protocols in future, like derivatives or anything you can imagine on the financial front, RWA or any kinds of thing. You can basically build on top of Fluid, on top of liquidity layer. So there is base liquidity layer, which is the base of the entire protocol, where all the liquidity stays. Now coming to the DEX protocol. DEX protocol allows as we discussed on the previously in the summary, it allows the purpose of smart collateral, smart debt, and so DEX protocol basically consists of basic functions, which is like swap in, swap out, deposit perfect. So these perfect operations. So swap in allows users to swap in a perfect amount. So user enters the perfect amount in, and they get the out amount. Swap out allows for the perfect out amount. Then there is deposit perfect, withdraw perfect, borrow perfect, and payback perfect. So basically, there are two different pools. Deposit and withdraw related operations happens on the smart collateral pool, and borrow and payback related operations happens on smart debt pool. So in one pool, internally there are two different pools, which is smart collateral and smart debt. And when you trade, either one pool can be enabled. Let's say only smart collateral is enabled. Either smart debt is enabled, or both can also be enabled at the same time. So when a user trade, if both pools are enabled, trade will route through both the pools. And on liquidity layer, it will just do a basic operations like deposit, payback, and borrow, withdraw for token which is going in and for token which is going out. So yeah, so deposit perfect. We've tried to write as much description in the code base as possible, but on deposit perfect, it allows users to deposit in perfect proportion. So whatever is the proportion of the pool right now, let's say pool has 1,000 ETH and 800 wrap stake ETH. So that so for each so if user wants to deposit 10 ETH, then they will also have to deposit 8 wrap stake ETH in the equal proportion. So deposit perfect allows users to deposit in perfect proportion. Withdraw perfect allows users to withdraw in perfect proportion. Similarly, borrow perfect allows users to borrow in perfect proportion of the smart debt pool. And payback perfect allows users to pay back in perfect proportion. So there's that. Now there are also other methods which allows users to deposit, do operations without perfect proportion. So for example, user just wants to deposit ETH in the ETH wrap stake ETH pool, then they can use this improper function, which is deposit, withdraw, borrow, and payback. These functions allow users to deposit whatever the token amount they want. It does an internal swap and gives and allocate the shares to users accordingly. So users' final position will be in both the tokens, but it will allow users to supply in a single token, do an internal swap, and uh, allocate the user's position into both the tokens. So this just allows users to have a much better user experience, because if someone were to supply collateral or borrow debt, they probably want to supply in one token, borrow in one token, rather than in perfect amount. So these functions serve that purpose. Then there is two other function, which is withdraw perfect in one token, payback perfect in one token. Basically, it allows how much shares to withdraw, but user can choose which token they want to withdraw in. So yeah, and similarly on the payback perfect in one token, as name suggests, pretty straightforward. So yeah, so this is the basic functionality of the overall protocol. Nothing much super complex here. And yeah, and there is also arbitrage function, and these are all many. There are many other internal helper functions, which is basically if there is any arbitrage available between smart collateral and smart debt pool, then arbitrage just does that. The pool also has its own oracle with any kinds of swap transaction that involves swap. The oracle price updates, and we have created the most efficient oracle till now, which probably allows users to fetch last 15 minutes of data in under 20K or 30K gas. So yeah, so there is the oracle, and and that's overall the magic. That's overall the major external functionality. Just to add more details on it, these function deposit, borrow, payback, withdraw, etc. These are user based. These are LP based function who wants to deposit or who wants to borrow something from the protocol. And the swap is anyone who wants to trade. That's trader related function. These are LP related functions. So that's that. Now there is one thing which is so anything, any call, any function that user is trying to call, and if it doesn't exist, it goes into fallback. And fallback basically delegates the call to the admin implementation, which is here. So, due to the vast size of the code base, we have segregated different logics. So, anything that any function that doesn't exist in this contract is basically gets for delegated call to the admin module. It checks that only authority can call this function, and authority is basically governance in most or almost all the cases. So only authority can do the fallback, and basically so governance can do the fallback, and fallback redirects to the admin module, where admin can do a lot of setups, which is basically turn on smart collateral, set any kinds of config, the rebalancing of pool or anything. So there are a lot of things there are a lot of configs in the overall protocol, which allows extreme level of flexibility. The pool doesn't have to be 50s to 50. It can be in any proportion. 20s to 80, 60s to 40, or any kind of proportion, 50s to 50, 40s to 60. So basically, all these config modules, it allows you the governance to set the pool accordingly. So for example, if there is a pool of ETH, wrap stake ETH, we might want the smart collateral wrap stake ETH liquidity to be just 20% and ETH liquidity to be 100%. So oh, sorry, ETH liquidity to be 80%. So that because in the wrap stake ETH pool, wrap stake ETH liquidity is just sitting idle, not used. So there is ETH liquidity is a more important thing there. So basically, there are a lot of configs. I can get in detail if it's needed, but there is a lot of things, and also in the overall code base. Uh, in the entire fluid code base, not just the DEX protocol, we have used the bits allocation rather than defining a structure or anything to have more flexibility and to pack as much data as possible into a single slot without defining new storage variables because that takes a lot of gas. So rather than so as you can see, we are allocating particular variables into different bits in the storage slot. So we can see this in the entire code base, and it's the same format we're following in the entire fluids code base, which is also the same thing we're following on the DEX protocol. So that's the basic overview of the entire protocol. Then basically the deployment of the pool happens through the DEX factory. DEX factory deploys the pool, and pool is not usable unless it's listed on the liquidity layer. So when the pool is deployed with the governance proposal, we need to list and set configs for the pool on the liquidity layer to supply and borrow. And once the limits and configs are set on liquidity layer, then only the DEX pool is really active. So unlike Uniswap, it's not an open DEX protocol that anyone can come and deploy their own DEX pool. Rather, everything is routed from the governance. So team will deploy whatever pool makes sense. And we're planning to deploy all kinds of major pools, which is ETH, USDC, ETH, Wrap BTC, ETH, Wrap Stake ETH, USDC, USDT, and so on. So yeah, I mean, that's the overall overview. If there is any particular thing I should get into, I can get into that as well. Yeah, and I've already we've already listed most of the things here, the basic understanding and info of the protocol. For anyone who wants to get a better understanding, they can just follow the DEX protocol article, the overall fluids article, and also the formulas, which we have added, the derivation of the formulas, which we are using internally in the function. So, yeah, I mean, there's that. I can add more things if there is any particular question, but this is the overall overview of the code base. Everything else we have already mentioned in the doc. So how to run the code base, how to start on our repo. We have mentioned how user can easily get started. So yeah, and and we will be active on the Discord to answer any questions or anything. But yeah, I think that's it from my end.
One thing I don't remember if you mentioned that smart debt is an inverse of AMM. So if we have stake ETH pool of 20 to 80% composition, where it's 20%
Yeah.
in stake ETH and 80% in ETH, then smart debt will be inverse of that. So it will be 80% in stake ETH and 20% in ETH.
Yes. Yes, I mean, so there's also, there's that thing. So debt is in an inverse way. So wrap sticky debt basically relates to ETH liquidity, and ETH debt basically relates to wrap sticky liquidity. Also, like to better understand it, we've also listed it in the article so that user can understand it. But yeah, as TMS said.
I guess a question from my side, and there might not be, a specific area, but is there, a specific area in the code base that, you want people to kind of hone
Uh,
in on?
yes, that's a good question. So the good area of the code base to focus on is so there is so admin module in general is simple, but the core module and the core code of the DEX is quite complex. There are a lot of derivation, a lot of formulas that are there. For example, there is a lot of algebraic equations. We've also added it in the derivation things. So basically, we've coded this quadratic equation, algebraic equations into the code base, and having more focus over there, like can some amount result in some kind of manipulation, or uh, not provide precise value, or hacker can benefit in any way, or some of those questions, or can it break in any scenarios. Those will be the good areas to focus on, because that's just pure math, and there can be some tricky numbers which can do some kind of impact. The other logical thing in the code base is the Oracle thing, how we are storing things. It follows a lot of Oracle, and it follows mm, quite a different logics to optimize it very intensely. So that will also be a nice part, because it's very logical intensive, and that can be some possibility of some bugs. But aside from that, other than these derivations, it's just basic operations. So these mathematical parts are the one which I think most will be most severe. No, I mean, we'll be pretty active on any new doubts that might come up, but we have a lot of details out there already. As I mentioned, the blog post, and those will be the good place to start to get a idea from users' perspective, how what protocol provides, and how protocol does it. We've already explored the derivation and all these things and the code base. So I think we've covered pretty much everything. We'll be happy to answer any other questions that might come up over here at Discord.
Awesome. Thank you so much. I will save this recording straight after this and get it on YouTube and share it with the channel.
Yeah, sounds good.
I appreciate you both running through this today.
Yeah, likewise. Yeah, awesome then.
Cool.
Thank you, everyone.
Good luck.
Yeah, thank you.
Bye.
Thank you. Yeah.